So there's two things I want to talk about that relate to sort of engineering at Square. So I'm at core an engineer. I like to write code and sort of solve product problems through code. But because Square touches dollars, quite a lot of dollars, so it's about 20 billion annualized. So this means that last month, multiplied by 12, you get 20 billion. A mistake is quite expensive, and we need to be very, very sensitive about sort of in everything we do, making sure we don't leak and sort of cause security problems. But in particular, I want to talk about one aspect of security, which is privacy, and making sure that we are conscious of our sellers' data, and we are conscious of the card members who sort of swipe their cards and trust us to make sure that we don't double charge them, and we don't leak their data, and we don't have one of the very many security incidents. You're sort of always shocked to hear that banks have lost many, many credit cards somehow. And I also wanted to talk about how, even though in every product we build, the security is very, very important, we are trying to be a startup, which means growing very, very quickly. So we're 4 years old, or actually just turned 5, and we have 250 engineers already, which is far more than you can sort of put through a classic training pipeline, and making sure they are each conscious of all the security implications. So you've had to be quite careful about designing process and some core tools to make sure that each engineer is sort of capable of writing secure code, but not slowed down in actually executing and shipping fast and sort of functioning at a startup. So data privacy is one aspect of security. So I think there were some people who raised their hands as security guys. We're not going to be talking too much about firewalls and like sort of that level of security, partially because I kind of been told not to, and then because it's not, I don't think it affects engineers so much. If you think of a typical small startup, the security model is very much protect the outside, have strong firewalls, and then everything on the inside is sort of wild and woolly. But with Square, and with payment companies in general, I think now more and more, because of all the privacy news, people are starting to be wondering about how to make sure that data does not leak, and they trust customers' data, place more care in how you use customers' data. So there's a spectrum of data that matters, right? So if you imagine Square, sort of in payment processing, Social Security numbers and bank account numbers are incredibly important to protect. People's names are important from like a pure privacy aspect, but then things like the size of each transaction is a bit less important. So basically there's a gradient. And we're mainly going to focus on like sort of the super secure, the data that's sort of most sensitive. And what that requires is, in design, the correctness has to come from an end-to-end story about how the data is never leaked. But because the design is continually fluctuating and things change over time, we need to have layers that sort of protect us from introducing code and new code that leaks secrets. So a core tenet of Square's sort of concept around security is to have a secrets service, which we actually call something else because it's impossible to pronounce. But the idea is it's basically a key value store where we insert data, like classically we'll put in a bank account, we put in social security numbers, sort of Square's keys to the kingdom go inside of here. And the API is very, very simple. So you insert a secret and you get back this random token that in no way can be associated with what it maps to. And you use this everywhere. And there's a lot of thought and care putting into making sure this thing is actually secure. So there's stuff about hardware security modules. There's stuff where you can basically take the data off the machine. Like if you just copy the database stuff and remove it from the hardware and you try and boot another machine, it is not actually accessible because the encryption sort of happens in hardware. But all of this is sort of available to engineers within Square as a pure key value service. So anytime you have to access, so imagine you're trying to take a credit card transaction. The key piece of data is what is the credit card number. And you don't have to worry about, gee, how do I make sure that I don't leak this? You simply insert it into the secret service, and you use this token everywhere when you're referring to it. And through sort of one API like this, engineers are protected from having to know more or less anything about security, right? If you trust sort of the abstraction, then you can write secure code by default, and there's no sort of additional complexity there. And it lets you move very, very quickly. Engineers understand key value stores. They're very simple. Right? This particular one is backed by a MySQL database, but that's totally irrelevant. Right? It's a very simple API to understand and to use. And the other part of making sure we don't leak data is around credit card numbers. And you don't have much control over sort of the distributed service that is Square. So we have our data centers, right, which they're physically protected. We chose a data center provider that's quite expensive, but sort of very, very focused on making sure people don't have physical access. But the reality is that our clients are running on people's phones, right, which potentially have been sideloaded. There might be viruses there. And how do we make sure that they're not stealing encryption data, credit card data, while merrily swiping credit cards? So what we've actually designed is in this piece of hardware. This is our latest sort of reader we launched about a month ago. And it's actually quite incredible. So it's the size of the iPhone, right? It's quite cheap to manufacture, in the sense that we basically give them away. And there's no battery. But even so, as soon as you swipe a credit card through it, there's actually a hardware bit on it that goes and encrypts the credit card number. So if you were not running the Square app, but you tried to run a microphone or whatever, it comes out as pure noise. Unfortunately, couldn't get a demo to work, but it's very excruciating. It's just pure noise. And each reader has a separate encryption key. So in the factory, they're basically burnt in, unique to each reader, the key. But what's interesting about that is that then we can go and feed it into our risk system. So because each reader is uniquely identified in how it encrypts the credit card code, we can actually create a story around how many readers are being flipped into a phone, whether the reader is being reused between multiple phones, and then use this as an extra signal when trying to decide how much risk and fraud there potentially is with the transaction. And if you imagine Square as a business, sort of our top line revenue comes through building better product, driving more revenue, and having people use us in more and more and more stores. But at the end of the day, our profits, sort of the bottom line, comes from being very, very sensitive to how we manage risk and not exposing ourselves to more, basically to fraudulent readers. So if you imagine, to give you one little example of ways Square could be abused, if a credit card gets stolen, the first question that comes to mind is, has this credit card been, is it basically available and can I swipe and take payments on it? In the old days, you'd have to go to a coffee shop, right, and try and charge it. And if it didn't work, there's embarrassment, there's like the security risk that maybe you'd be, sort of caught, so to speak, or you have to pay cash. Now with sort of any of the mobile providers, not just Square, right, you can sort of pull your phone out and try and charge it for $1 just to see if it works. And these things sort of in the financial model of credit cards are quite expensive because not only are we out whatever the, not only are we out the extra $1, but there's this sort of extra fee, sort of what's called a chargeback, that can become quite expensive. And if there's too many of them, then sort of our ability to process credit cards gets shut down by banks because they're felt we're too risky. So this sort of all comes together in that, from that one little piece of hardware. It's quite incredible. Yeah. But sort of in practice, so we have our secret service. Developers are using it. We hope, right? So what happens when they ship code, they introduce a bug? How do we limit our exposure? So what we have developed is basically a system of layers that are a combination of process and technology, right? That I think on their own, each one's quite simple, but together they creates quite a good blend of catching bugs, limiting the amount of exposure we get from them, but also keeping developers agile. And I think that's very hard to do, especially having process that helps developers and makes them sort of move faster, as opposed to slowing them down, is quite a trick. And I think we've done a good job of it. But let me give you 5 sort of hand-picked examples of how we do this. So one is, within Square, our entire architecture has been very much influenced by Google because our CTO was sort of at Google for many years. We hired many Googlers. They've basically tried to rebuild Google. And so we have a service container, and it's built through protocol buffers. You can very easily map down that this is sort of the message that your service sends, this is sort of the endpoints it has, and very quickly build out basic services. And they have instrumentation around, this is the amount of resources they need, it's memory intensive, so let's keep it on memory intensive hosts. There's stuff around automatically routing requests based on whether a service endpoint is healthy or not. There's stuff around making sure that requests stay within data centers, but failing over if the data center is down. And around this sort of, or in this world, we have these annotations. So one of them is redacted. It's like this. So when you create, for example, a payment message, and this is like a very sort of minimal one, imagine that you have this name. So debugging is something every developer wants to do. And sort of a core tension of engineering is that you want as much data as possible to help debug the problem. But then from a privacy standpoint, we don't want to give you much data at all. In fact, we want to give you ideally 0. So how do you resolve the two? So through things like this redacted option, basically we can continue to log every request and show this in various sort of profiling and debugging tools, but know what fields are considered especially sensitive and almost not relevant to what you need to see. So redacted will mean that it's sort of X'd out. We have another field that will basically hide it by crypting, so by hashing. So you can tell if it's the same value, right? But you won't actually be able to know sort of what lies underneath. And so what happens is that when a developer accidentally turns on the spew and they start, they save a log to their personal laptop, the amount of data that's sort of available there is very, very small. However, you can leave the annotation off, right? So another thing we do is that we automatically scrub logs for suspicious-looking pieces of data. So this is pretty easy to do for particular kinds of numbers. So any number of that form really, really looks like a social security number, and we just remove it through pure regex. There's a bit of complexity around removing things like names. We don't do a hugely great job of it. But it's an extra layer to sort of help limit the amount of data exposure that happens during a bug. And then we want to prevent bugs in the first place. So we have, as part of our development methodology, we're very, very large on pairing. We think it's an effective way to help developers on board and sort of learn relatively sophisticated systems. And we actually enforce this at the, in our case, we use GitHub, but we enforce it at the source control level. So you cannot merge into a master branch without having at least one other developer sign off on your commit. This is classically done by letting another developer do your merge. And sort of a corollary to that is we are very, very insane about testing. We have tests for basically everything. They are excruciatingly slow to run. If you were to try and run them just on your laptop, they would take, at last count, just about 36 hours. But we've gone and built sort of a custom tool that will parallelize the testing across a couple hundred AWS hosts, making it much more palatable. So it takes about 5 to 10 minutes. And every single commit that gets sort of pushed to central repos is tested. Then must go green before it's merged into master. And this is, I'll tie it together in a second. So with the pairing in production, it's sort of more of an operational feature. And I think it's something actually most companies do, but it's worth emphasizing, which is that anytime you are in a production system, right, you must be with someone else. This is not something you can kind of really enforce from a technological standpoint. They could try and do like the double key thing. But it's just sort of a good sense of having someone else see code you run and make sure that you're not either one, deleting data or doing something quite foolish, or basically being exposed to more data than you need to be. So you might imagine to track down the bug in production, you want to figure out, you have to look at some real life data. But one of the things we always ask ourselves is, what is the data we care about? And can we basically, if we're pulling out a database row, what are the columns we care about? And are very, very paranoid about not using more than that. So we would not use the name if all we needed was a timestamp. So pulled all together, the real goal of this is sort of twofold, right? So it's very important that we not make mistakes and not sort of lose data. In general, these mistakes kind of have, not much of a cost. The most important part is to not be consistently making mistakes, because that's how you get basically holes. And through that, we feel this notion of end-to-end correctness is where it comes from. So things like the secret service and making sure it's always used means that we have a single place within our data centers that we have to enforce and protect, although it's actually multiple places. And we have a notion sort of extended to access control as well. So there's a few different services that each own a particular pile of data, and it is their responsibility to make sure that each request that they receive is authenticated. We have sort of the inverse almost of the security at the outside, and everything within is trusted. Security for us is at the core, right as close to the data as it possibly can be, and that's where things are validated. And while we have additional layers around that, those layers are protection against sort of bugs and to offer sort of a better developer or customer experience in some cases. But the thing I would try and keep in mind is that if you do the process correctly, you can actually get it out of the developer's way to where someone who joins Square can do a production commit in like 2 or 3 days and not worry that it breaks production. This is actually, if you fully embrace it, it's greatly empowering because it means that you as a developer can go and touch any system within Square and be quite confident that you are not going to cause a security problem and you're not, ideally going to introduce sort of correct behavioral bugs either. But security is sort of the thing we care most about. So the other sort of thing I wanted to talk about was actually also finance-driven, but from a different angle, which is how availability and sort of the classic concepts of availability are slightly different when you're dealing with money. So classically, an available system is one that you expect it to give you a correct response within some very finite amount of time. With payment processing, it's a little bit different. So the correct response for a seller, they don't really care about what's the RPC, what went over the network. All they want to trust is that they swipe a credit card and they'll receive the money for it. So they don't care where the money comes from, right? They just want the money. And it's sort of our job almost to make sure that we get the money from the credit card holder. But there's various ways we can sort of make up for systems that are down and unavailable by effectively using our own money, floating it, exposing ourselves to risk, but carefully managed. It's a way sort of using the financial underpinnings we have of buying uptime relatively cheaply, actually. So this is, was not approved by our design group, but basically it's a very rough sketch of what networks are touched when you swipe your credit card in an ideal world. So one, there's this magnetic sort of field that gets manipulated when you swipe at the right speed. There's within the reader, it basically takes the digital reading off of the magnet thing, encrypts it, encodes it as an analog signal, sends it into the phone. The phone then decrypts, sort of converts the analog signal to a digital value using very 90s modems technology. Does the computation it needs to, and then it will send it either over Wi-Fi or 4G or 3G or I don't know what, maybe 2G. In the worst case, the sort of Square servers, and then Square will go and talk to the bank, make sure you have the funds in an ideal world, and then it will send a response back to the cell phone saying that you have been charged. There's quite a few places this can go wrong, right? So one place is between Square and the bank. So there's actually quite a few banks. These are many billions of dollars, and there's not just technology. You can't just fail over from one bank to another. There's all this sort of contractual obligations that we have to fulfill. So if a bank isn't responding, the obvious thing to do is you can create basically a backlog. Right? So you can either fail the request, which is sort of shitty, or you can use a classic journal, stick entries in there, and then when the bank becomes available, flush it. The problem is, what do you tell the merchant in the meantime? And one thing we can choose to do is basically take on the risk that the credit card is either invalid or going to be declined, and basically eat it so that we can offer a better experience for merchants. Realistically, the banks don't go down that often. Sometimes it just takes longer. And we might choose to do this not so much because they're unavailable, but because we want to hit a different latency requirement than they can realistically offer us. So we might want to offer a response within half a second, but the best the bank's willing to commit to is 2 or 3 seconds. The other part is around sort of this part of the network, right, where either the magnetic card is sort of not swiping or the reader is broken. It happens. And we work very, very hard to make the reader as strong as we can, but ultimately it's in the merchant's power to make up for this. They can either ask for another credit card or they can ask for cash, or most of them have been sort of trained to keep an extra reader alongside just in case there's problems. But the part that's really interesting is actually this, right? So what happens if the cellular network is unavailable or the Wi-Fi network is unavailable? And this happens quite often. It's one of the biggest complaints we get from merchants. And the thing you can do here is very similar to what we do with the banks, where we will log the request, assume it to be approved, and then, when available, flush them through to Square and ultimately get the money back. But the problem is if you look at Square's growth, when we first sort of launched 4 or 5 years ago, the key feature we had was that suddenly all these people who could not accept payments or be signed onto a typical credit card processor because of all the fees and sort of the process required there are on Square. And they're mom and pop shops, they're farmers market-y type stands. They're small operators and they're not hugely sophisticated. Like ideally, they don't want to be thinking about any of this at all. And if we do the logs approach, we're either exposing Square to a significant amount of financial risk, because you can imagine there's quite a few ways of abusing this. You take a bad credit card and you keep swiping it for $100, right? Or you have to basically educate the merchant that there is a decline risk, and you have to give them controls. So for sophisticated merchants, for larger ones, this is a totally standard thing. If you look at any of the larger coffee shops or any of the larger fast food restaurants, they will all basically accept credit cards even if the internet's completely down, and then in the future they will flush the logs because they've run the numbers and they think they sort of understand what's going on. But how do you explain this to a merchant who doesn't fully understand basically how the credit card works? And part of the idea is that you can offer better controls, so you can say up to $25. The other part of this goes into who at the merchant store is sort of enabled to make decisions about the merchant's financial exposure, right? It should not really be the cashier. It probably wants to be the owner. So how do you sort of offer this feature to them, and like basically what is the product design that goes into educating our merchants to drive sort of a better product? And finally, with any new product, right, the security guys get involved, and in their minds, this is suddenly a brand new attack vector, right? If you were to sideload some little, let's call it virus on your phone, right, it could try and manipulate sort of the in-memory information about how much was charged, who was charged, and things like that. And you can also imagine that if you were to lose the device or it would break, you're basically out the money as well because we cannot flush your logs. So those are I think two different parts of Square that I think most people will find a bit surprising, right? So one is the the financial parts and sort of how, in many ways, you might be slowed down because of the fact we're dealing with money, but sort of put together and correctly managed, I think we can make engineers move faster. But then also through how we're dealing with money lets us build sort of interesting products. So one other little anecdote that I always find sort of super cute is if you think about database lag, it's usually an arbitrary number, right? It's 2 to 5 seconds. But for us, we can actually quantify how many dollars are represented by that 2 to 5 seconds. So if we were to lose a database and lose 2 to 5 seconds of basically transactions and knowing who to charge, we can attach a number to it and very rationally decide, is this worth improving? And shockingly enough, it rarely is. So it's sort of fun to be able to throw money at some of these problems and basically buy better availability. But, yeah. So, any questions about I don't think so. Go for it. Oh, sorry. So the question is basically, in Europe in particular, there's this drive for chip and pin, right? So instead of swiping your credit card and signing, you stick your credit card in the machine. It has this little electronic chip, and you enter a PIN number, and through this is validated. It's sort of generally believed to be far more secure than swiping because of the sort of two-factor aspect of it. We'd like to get bigger as a company, right? So these are things we're thinking about quite carefully. I'd imagine the hardware would be quite different, but otherwise we haven't announced any plans for the chip and pin world. Oh, it's completely, sorry, so the question was, how exactly does it work that you plug this little device into the microphone port and it sends data to your app. The app effectively starts recording. So one of the things that's, if you think about the power requirements of encryption and making sure that the card swipe is read and all of that, you might think they would actually also turn on the speaker part to effectively drive a very sort of passive source of power into the reader. But we have sort of advanced in sophistication enough to where we can build our own chips. So this is not necessary. But at core, the reader creates a sound. So it's not really easy to do anymore, but you used to be able to plug it into your microphone and then swipe a card and hear this terrible sort of noise, basically. This Square app knows how to understand that noise, basically.
So if I select a low-risk card,
Mm-hmm.
something that approximates a credit card, can you tell the difference, or is there?
Yeah, so I mean, we try. So something so there's all kinds of standards that go into the data that's on the cards. There's usually two tracks. One of them has your name and a particular set of fields. The other track has a few other fields, and you also can negotiate better rates depending on which track you use. But sort of at core, yes, we can identify what kind of card it is, and you can try and swipe your Metro card or something. Those actually don't work with our reader, but from a few other cities they do. But it's just bogus. I mean, it has no meaning as a credit card. So in the same way, you can type random digits into a website.
So I guess
There's two sources of power. There's one is from basically the background noise, so to speak. So by the way, I'm not a hardware guy, but from in my understanding, there's background noise that sort of is one source of power, and then yes, there's actually quite a bit just comes from the act of swiping. Number. Sorry. So the question was, how do we manage risk, sort of at Square, in particular around sort of catching fraudulent charges? Going back to the 200 employees number, we have a very significant amount who sort of are focused on combating fraud. How much we can talk there is relatively limited because you don't want to sort of give too much information and just bad things happen. So we can talk a little bit offline. Sorry, going back to how it could work question. I mean, so it knows when you swipe the card, right? It basically sucks down a bunch of random bytes. So there are little readers you can buy that'll show you what's on the card. It's totally in the plain text. It's going to be your name, possibly slightly cut off, and then all the numbers that are on the card. And there's an extra piece of data that lets you know that the number was retrieved from the swipe as opposed to just read off. But the data is either there or it isn't there, and it might be corrupted, but it's hard to tell. To some extent, we have tried and be sort of sophisticated about detecting bad cards as early as we can because it offers a better customer experience. But at the end of the day, you cannot tell whether or not it's a real credit card until you charge it. So, sure. So, I mean, the question is, on one hand, you don't want credit developers to have access to credit card information. On the other hand, how do the developers develop? So, I mean, clearly in staging, you can feed, so in what sense do you think there's a challenge? The production system, sure, gets numbers that are valid and meaningful credit card numbers. And then, in testing, we have a certain suite of credit cards that, the numbers are designed for testing, right? And then we can also make sure that the requests never leave the system. But in a completely full and mocked and staging environment, you can totally look at everything that's going on because all the data is fake. It's not actually that. The fact you cannot see the credit card numbers is not really that onerous because you sort of build the system and then you trust that it works. Sure. So we have, this is sort of the role of the secret service where you want to compartmentalize where these things are kept. So this is actually very sensitive, where are the decryption keys, and they're kept alongside bank accounts and sort of social security numbers, or let me rephrase, with the same level of care. And there's a lot of them, sure. We basically have one for every reader we've manufactured, right? Which is, a superset of all the readers we've ever given out. And there's, a service that's sort of specialty is basically translating the request as we receive it from our phone, decrypting everything, attaching a bit of extra metadata that it needs to, and then sending that to the bank. Because the bank does not understand any of our gibberish, right? Yeah, so I sort of glossed over the what's inside of Square part. We have, I mean, it's a large corp, right? So we use some of everything. We do use MySQL quite extensively. We used to use Postgres, sort of full speed. We are unhappy with some aspects of its scaling, in particular that it scales quite well, but at some point it sort of hits a cliff and it goes to 0, which is not like a behavior you want. Like, you rather want like a slower sort of failure mode, where basically things slow down as linearly with the amount of extra load. But we still do use some amount of Postgres. We're starting to use React quite heavily. We do use HBase and sort of big table-y type stores quite a bit. We use a lot of Redis. We actually don't use any memcache, as far as I know. And then in terms of like technologies, we use a lot of Java, a lot of Ruby, a lot of, actually now we're starting to use Node. We use some Postgres, sorry, not Postgres, right? But we also use like protocol buffers to sort of do communications, and we've built a lot of things in-house as well, sort of over time. So like one of the things is the service container. That means you can ship sort of a service that talks to another service very, very quickly. So the question is, how do we do analytics? So we're very, very paranoid about analytics. That's sort of going with most things. We used to use a lot of graphite. It doesn't scale. So we're starting to use OpenTSDB, which doesn't scale in a slightly different way. But it's like generally better. So I assumed you meant operational analytics, right? Because there's different. Interesting. OK, so let me tell you about operational data, and I'll think about what I can tell you about the other stuff. So, and then the other half of this is, so it's nice to basically get Graphite and OpenTSDB will act as sources of seeing as things are trending over time. But in terms of alerting, we use the classic Nagios with a few custom written sort of extensions. And in terms of what our analytics, we use sort of business analytics almost to an extent. Right? We have the classic like bit of Tableau. We're reaching the point that sort of I think most companies do, where we're going to build our own. And in terms of the features that support, I mean, you can imagine there's some amount of online making sure, sort of validating that payments are not obviously wrong. There's some amount of like offline trying to train systems that are better and better at catching things. One of the things we kind of think about quite a bit is sort of how to leverage our data to build better products. Like risk is one of the big things. Sort of as I mentioned earlier, like managing our risk is a huge part of sort of, and really for any credit card processor, it's a huge part of our profitability, which is another reason can't talk about it too much. So I mean, it's hard to speculate too much about about the other pay-and processors things in terms of our its attention. So like obviously we could do with a lot of, if you look at fast food restaurants, they don't even bother like doing any validation. They just immediately will accept because they want the line to liquidate itself as quick as possible. That's the biggest concern. For us, we could obviously do the same thing, and might even be a feature at some point in the future we expose to merchants to basically make the same choice. But in terms of, for us, it's a balance between building a better, sort of a better experience that sort of works faster and not losing much money. There's like the bigger lag issues really have to do with things like 4G being quite slow and like seeing the connection and sending it from the phone like to the to our data center. This is usually much like, in fact, it's almost always the problem, and not from Square to the banks. That's just sort of easier to like model and understand. But please.
So for fraud prevention, one of the main ways that you can do it is profiling your customers, right? But given that you get a different token every time you swipe a credit card, there's no way to really link usage patterns for a specific account or specific customers. So how do you go about, or is it
So I mean, the token is not generated at the reader level, right? So the thing that's important is the reader has to be able to, we have to be able to decrypt what's there, right? So there's additional information sort of beyond like the credit card that gets added, right? So there's basic stuff about information about the device itself, right? So like what version it is and basic statistical things like that. And then there's, this piece of data is wrapped in the package the phone sends, right? So it will send information like, what did you buy, so it can send you a receipt through email. So we do have quite a bit. So we do have all the data, and then the tokens get generated sort of at the internal sort of service, because whenever you need to be able to refer to a credit card, you don't want to use the credit card number. You want to be able to use the sort of sufficiently unique token, and that's where it is. Like all of our internal like databases don't have credit card numbers, except for the very one special place that does.
Associated with the device.
Yeah, so I mean, how much, let's see. So speaking of guys at USB sticks, so there's this notion of hardware security modules that have these bizarre requirements. So one is that they get burnt in with the code at the factory, and you have to deliver, so if you choose the code, and you have to deliver it to them using like 3 separate sort of certified couriers going on 3 separate days, and it's all slightly ridiculous, but very James Bondy. In terms of the factory thing, I mean, that might be one way to do it. Sort of, it's unclear why you need a human to be involved, right? Yes, I think if you sort of think about it, sort of removing the humans from the equation, then there's ways you can make it work. So I pretty intentionally gave no details about how the what kind of encryption this is. So yes, we do, however, have we made a blog post around sort of the work that went into the device, which might have actually more information than I'm sort of so I don't have a handler here today. So there might be more information that can sort of answer your question. But, yeah. So Square at core wants to do commerce. If you roll up to a merchant and you want to pay with whatever you want, and they were willing to accept it, there's no reason we don't support it. You cannot currently pay with Bitcoin on Square. So. Goodness. Anything else?
Have you guys done anything about the target range?
Not that I know of, but broadly, I'd refer you to like our external communications. So. I'm sorry? Oh, so I think the question is like, what happens if you use the pay with your name, I guess, feature? Sure. So basically, this so the idea, the way this works for those who sort of haven't tried it, is you can go to a merchant, Square merchant, buy a few things, and instead of using your credit card to pay, you can pull your phone out, sort of through geofencing type things. It knows that you're at the merchant, and it'll sort of pop up on their screen, and then you can say that, hey, put it on my tab, I'm George. So the experience it's trying to model is one of a cafe that you're sort of consistently coming back to, and they know you by name. From like a credit card processing standpoint, it's pretty like, they basically pick your face, we know what account it is, and then internally within Square, right, we sort of bill the credit card you have on file. We do, because there's no card involved, for us, it's something called a card not present transaction. To build a better product, we charge the merchant the same amount, but that's like, a product detail. So there's no real additional complexity there. And in fact, it's almost the easiest to think, because there's no hardware involved, and it's similar to like, you have an account on Amazon and they just charge your credit card. So, please.
You mentioned spinning out AWS instances for running tests. Do you have all your infrastructure there at AWS, or is there a data center, or what?
No, we don't. We have dedicated data centers, quite a few of them. But AWS is like an amazing resource for precisely this kind of thing, right? Because it's yeah. So. Okay, yeah, and we can speak offline.
So I know PayPal is also, they have a card reader product.
Yes.
How do you?
Yeah, there's quite a few of them now.
So we should start the product.
Well, so it's tricky. I would usually say Square without failure, but this is eBay, and they own PayPal. But we're happy to broadly. If you imagine the world before Square, it was quite a horror story. Anything involving credit card processing was just a disaster. And it's very nice that now there's quite a lot of competition in the space, and we're all working sort of to make it as easy as possible to buy things. So, all right. Thank you for listening.